Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So just like I made a video on May, June of 2025, two variants related to differentiation integration. This time I'm focusing on October, November 2025, variant 35 and variant 33. So I'm bracketing variant 33, variant 35 together, and my focus will be on differentiation and integration. And then I'll be making a video on differential equation because these three topics go together. So this one will be a separate video on differentiation integration, and this one will be a separate video. So now there are three questions related with differentiation integration. Let's have a look. Let's look at the first question. Now this first question is about differentiation of implicit equations. It says the curve has this equation. It involves ln and it's implicit. Find the exact value of the gradient of the curve at the point 2, 3. Give your answer in a simplified form, 5 marks. Now first of all, focus on this. X square is multiplying with ln 2y. And then negative sign, y is multiplying with ln of 2 plus x square, ln of 6 is a constant. So differentiate both sides with respect to x. X square into derivative of ln 2y, that is 2 over 2y, dy by dx. Because it's in terms of y, we write dy by dx. Negative sign as it is. And one more thing, this is u, this is v prime. Don't forget v in u prime. So now this is v as it is, and u prime is 2x. Negative sign in the middle, y as it is. Derivative of ln 2 plus x square, 2 plus x square goes down, 2x goes up. And then ln of 2 plus x square as it is, derivative of y is 1, but don't forget dy by dx. So now we have dy by dx, we have dy by dx over here. So dy by dx is gathered together, and I take this thing outside of the bracket and everything on the inside. So what is everything on the inside? 2 over 2y. This is 1 over y into x square over y. This one is this thing, ln 2 plus x square, that is inside this bracket. This is 2x into ln 2y. 2x into ln 2y. It was positive, taken to the other side becomes negative. This one was negative, taken to the other side becomes positive. Now what else is needed? Now what we do is that I have taken 2x common out. So let me take 2x common out. 2x is on the outside. I'm left with y over 2 plus x square, and this is 2x is common, ln of 2y. So now when we plug in the value, by the way, they are not asking us to make the subject. I'm just simplifying things for the answer to be simplified. So x is 2, y is 3. X is 2, x goes over here, x goes over here, here and here. And y is 3, that's the blue ones over here. When you simplify, this is what you can see. And I have taken LCM over here, I've taken LCM over here, I've simplified, and that is the answer in the exact form. It's fractions, integers, and then in terms of ln. So that is this thing. The next question is this one, that is question number 6. It says a curve has this equation, tangent x over 5 plus 2 sine x. Express dy by dx as a simplified fraction. So this is differentiation. That was also differentiation. This is differentiation and no stationary points. So this is differentiation and stationary points. That was implicit. Express dy by dx as a simplified fraction in terms of sine x. Now this is quotient rule. So let me write over here, y is equals to u over v. Therefore dy by dx, that is v u prime minus u v prime inside a bracket divided by v square. So now let's focus on this. Over here, this is u, this is u prime, this one is v, this is v prime. We are starting with v, so this is v, and this one is u prime. And this one is u, and this one is v prime. So let me highlight it. So therefore this is v, this is u prime, this is u, this is v prime, this is v square. Now I can write at the top for the examiner to have trust in me. That is, I'm writing sin x as s, I'm writing cos x as c for things to be simplified. So now over here, sec square x, I'm writing this thing as 1 over cos square. 5 plus 2 sine as it is. Tangent, sine over cos. This is cos over here, and this thing is that denominator over here. Let me just push it to the side, and I think I missed out the division sign. So that is the division sign over here, that is intact. So now simplify on the inside. This c cancels out. 5 plus 2s divided by c square minus s into 2. So now when I take LCM, what happens is that this c square gets multiplied over here. And that is the LCM. And then I have done one step a bit too quickly. So if you want, let me take it over here and let me write it like this. So this is the numerator still, this is the denominator. That is the LCM that was over here. So this is c square that is now replaced. So this c square is now replaced with 1 minus sine square. Okay. And this is my working on the sidelines, just like some kind of rough work. So let me write over here, this is my rough work that I did. So now over here, have a good look. This is 5 plus 2s into c square. C square is written as 1 minus s square. It's written over here, it's written over there. And then later on, I can transfer this thing 5 plus 2 sine the whole thing square over here in the very end. So that is how we get in a simplified form in terms of sine. Yes, there is sine, sine, sine at all the places. We want it completely in terms of sine. So yes, a little bit of algebra and simplification was tough. Now, show that the curve has no stationary points. When I make it equal to 0, sine cube is minus 5 over 2. So let me grab my calculator, and this is a cube root of negative 2.5. That comes out to be 1.357. So therefore, sine theta is coming out to be a negative 1.357. It's out of the range because sine x has a maximum value of 1, minimum value of minus 1. Therefore, since it has no solution, so therefore no stationary points. Since equation has no solution, therefore there are no stationary points. That is this one. Now this question, this is about integration, and integration, a particular technique known as substitution or change of variable. So now let's focus on this. So now it says use the substitution. U is equals to x square minus 3. Show that when you change over this thing, it becomes this thing. That is 4 marks where a and b are to be found. The limits, very easy. And then the next part that was on the next page, hence find the exact value of this integral. That's another 4 marks. So now when I get started with the working, so I do all the thing in one shot. So that is why I have wrote it over here, that up till here is part A. So now whenever we do the substitution thing, the rule is we always start with the dx part. We take this thing, we differentiate it first. So u is x square minus 3, du is 2x dx. That's the first thing. Also, I'm making x square the subject because I'll be needing it. X square is u plus 3. Now this x square into 2x into 2. So basically what I've done is that I have written 4x cube as 2 into 2x square into, actually 2 into x square into 2x. Got the idea? So now this 2x with dx. So now this 2x with dx, the green part, this 2x with this dx, that becomes du. This x square, that is the purple part. This x square, that is the purple part. And then this 2 is taken on the outside. This 2 is taken on the outside. So now can you feel it? This is that 2. This is that 2x You need to have a feeling of exactly what's going on. Otherwise, you will mess up things. So now this 2x dx, that is du. And that is du over here. This x square, that is u plus 3. X square is u plus 3. This 2 is on the outside. The square root of x square minus 3. X square minus 3 is u. So that is square root of u. So this 2 is there, this u plus 3 is there, this root u is there. What about the limits? You change it using the same equation. So we have this equation, u is x square minus 3. So let me write over here, u is x square minus 3. When we plug in x as root 12, this becomes 9. When we plug x as root 7, it becomes 4. So the smaller limit is 4, the upper limit is 9. So this is 4, this is 9 that I have written over here. This is the first part. Now the integration is pretty simple, nothing special. U divided by u power half is u power half. 3 divided by u power half is 3u minus half. Increase the power by 1, divide by the new power, division by 3 over 2, multiplication by 2/3. Division by half, the new power is multiplication by 2. And then you simplify. I have written this thing as u root u. This is root u. I've taken this as common. Now keep in mind the limits apply to everything. 2 is still on the outside. So this is the upper limit. That is root 9, 2/3 of 9 plus 6. This is root 4, 2/3 of 4 plus 6. The rest is all arithmetic, and this is the answer. Don't forget the 2 on the outside. So now that is this part. These are the 3 questions of this paper. Let me go over here. So now this is October, November 2025, variant 33. And my focus is on the differentiation and integration. So I see 3 questions over here. So now let me start with the first question. That is this. So this is differentiation. And this is, no, my bad, that's integration. So this is integration, that is by parts. This is algebra, this is trig, but the power of algebraic is 2. So this is a 2-step by parts thing. So the first step is this thing. U is x square, du is 2x dx. dv is sine 2x dx. Integrate, there is a negative sign. Yes, the coefficient comes out and divides. Then follow the arrows, u, v minus integral v du. So this is u, this is v. So let me highlight it. This is u, this is v. So this is v, this is u, and this is integral v du. So this is blue one is minus half cos 2x. So that is actually cancelling. This is 2x dx. Minus minus also cancels, becomes a plus. And this x is over here, this x is over here. The 2 and the 2 cancels out. Now there is still a product. So you have to start all over again. So u is x, du is 1 dx, dv is cos 2x, integral of cos is positive. 2 comes out and divides. So this thing, this whole box over here, that is inside this green box over here. X into half sine 2x, that is half sine 2x with a negative sign on the outside. Integral of sine is negative, negative, negative becomes positive. So negative, negative becomes positive. And then you have all these things. Now have a good look. Pi by 6 is the upper limit. That goes over here, that goes over here, that goes over here. 2 times pi by 6 is pi by 3. Cos of pi by 3 is half. 2 times pi by 6 is pi by 3. Sine of pi by 3 is root 3 over 2. 2 times pi by 6 is pi by 3. Cos of pi by 3 is half. Over here, we write x and square, pi by 6 and square. This is pi by 6 as it is. Lower limit is 0. 0 will make everything 0. 0 will make everything 0. Cos of 0 is 1. That is over here. The rest is simplification. We have pi square and pi and root and fractions and everything. I have done the fraction thing on the outside, and that is this question. That's the first one. Now the second question is this one over here. It says question number 11. Now this one was a good one, and I'll still double check if there is any other questions over here. Let me first double check using the thumbnail. No, that is this one. That's already marked. and there is this one question. So instead of 3, there were 2 questions over here. Okay. So now let's get back to it. Okay. So now the special thing in this one was this thing. The diagram shows a graph of y is equals to sec square x and square root of 3 plus tangent 2x. X lies between such and such. So x lies between these two values. The graph is drawn. The coordinates of m is marked, and we know that m will be negative. Find the x coordinate of m. So now over here, u is sec square x, derivative of sec square x. Now this is not a standard thing, but we talk only about sine, cos and tan, but now in the new formula booklet they have written it. So therefore the derivative of sec is sec x tan x. So now we are applying the chain rule over here. So this is basically sec x raised to power of 2. 2 comes down. Let me highlight it. So this is sec x raised to power of 2. 2 comes down. Power reduces by 1. Sec x secant remains as it is. Derivative of secant is sec x tan x from the formula booklet. Got the idea? V is 3 plus 2 tangent x, 3 plus 2 tan x raised to power of half. Half comes down. This remains as it is. Power reduces by 1 into derivative of bracket. This you can write it further as this 2 and 2 will cancel out. So this is sec square x divided by square root of 3 plus 2 tangent x. And I've written it down later on. So I've shown you the working. So this is an application of product rule. If y is uv, therefore dy by dx, that is uv prime plus vu prime. Got the idea? So now over here, this is this sec square x into this thing. This is u v prime. So this is u and this is v prime along with this. This is v and this is du 2 sec x tan x. So that is 2 sec square x tan x. This is v prime and this is u. So now let's simplify. First thing that I did is that I took common. So let me highlight things. So I took one of the sec square x common and I'm left with the rest on the inside. I did not take any LCM as such because I was any which way equaling it to 0. If I equal it to 0, sec square x is 0, 1 over cos square x is 0, cos square x is undefined. We know that it has no solution. Now when we take this thing, this whole thing, and when we equate it to 0, let me transfer this thing to the other side. So this minus sign remains. Now let me cross multiply. So now over here, this thing, the square root, that gives this thing, the square root disappears. This is this concept, root A equals to A. That is this concept of indices, surds used over here. So sec square x is minus 2 tangent x, 3 plus 2 tan x. Sec square x, now write it as what? So sec square x is equals to 1 plus tan square x. We have everything in terms of tan. So now 5 tan square x plus 6 tan x plus 1 equals to 0. We are lucky. This is middle term factorization. So middle term factorization gives us two values of tangent. One is negative 1. Basic angle is 1. But we are going from negative pi by 4 and pi by 4. And both answers are good. But that is the end points. So reject because m is in between. M is not this thing. Tangent x is equals to negative 1/5. Basic angle, we get alpha is 0.1974. Correct to 4 SF at least. So in the fourth quadrant, that's 0.197. In the first quadrant is this thing. This is fourth quadrant clockwise. This is first quadrant anti-clockwise. From the graph, we know that this is the answer and that is what we focus on. So now let's move to the next part. And that is on the next page. That is this one. Using the substitution, u is 3 plus 2 tangent x. Find the exact value of the area of the region bounded by the curve, the x-axis, the line x is negative pi by 4, line x is equals to pi by 4. So technically, we want the area under the graph. So it is simple integration and using substitution. So u is 3 plus 2 tangent x. So this thing over here, the equation, this will be replaced with root u. So let me highlight it. This is root u over here. Then when we differentiate it, du is 3 becomes 0, 2 as it is, 6 square x dx. We have 6 square x, we have dx. So that is replaced by half du. So that is replaced by half d. Now let's talk about the limits. The lower limit is pi by 4, upper limit is lower limit is negative pi by 4, upper limit is positive pi by 4. This is the equation that relates u in x. When we plug in negative pi by 4, tangent of negative pi by 4 is negative 1. This comes out to be 1. So the lower limit is 1. So this one is the green one, that is the lower limit. And when we plug in positive pi by 4 in this equation, we get u is equals to 5, we get u is equals to 5. So now it's a very basic integration. Half as it is. U has a power of half, increase the power by 1, divide by the new power. 3 over 2 after flipping becomes 2/3 into half, that comes out to be 1/3. U raised to power of 3 over 2 can be written as u root u. Let me plug in 5, let me plug in 1, simplify, that is the answer. So now we are all done and dusted with our variant 33, variant 35, and we did questions on differentiation, we did questions on integration. This is from May, June, actually October, November, because I'm mixing things up over here because there are so many papers. So October, November 2025. So this is all done and dusted. Stay tuned for more content on Mathematics with Shahab Yaqub.